For our final project, we chose to implement cell shading. Cell shading is a non-photorealistic rendering technique frequently used in video games. For our project, we implemented a standard cell shader, then extended it using a technique called Xtoon shading. Finally, we implemented a watercolor effect that we believe produces truly aesthetically pleasing results. To implement standard cell shading, we use the Blin-Phong model. First, we choose from a discrete set of diffuse colors based on the diffuse term of the model. Second, we set a full white highlight based on the specular term of the model. Finally, we detect outlines by finding vertices with normals close to orthogonal to the camera direction. We shift these vertices to inflate the model and color them with an outline color. We extended our shader using a technique called Xtoon shading. Xtoon shading replaces our diffuse color set with a 2D color texture. This lets us use a detail heuristic to help choose which color to shade in. In practice, we've used distance to the camera as our detail heuristic. As our model is viewed from further and further away, its diffuse colors become more blended, creating an effect called level of abstraction. We have also used Xtoon shading to create a backlighting effect, as seen on our teapot model. Finally, we implemented a 3-pass watercolor effect. In the first pass, we render a full frame buffer using Xtoon shading. In the second pass, we use a paper texture to simulate the way watercolor flows anisotropically onto paper. The texture displaces color within the first pass frame buffer, which we use to output fragments for our model. In the third pass, we use a Sobel edge detection filter to darken the edges of the second pass frame buffer with a brushstroke effect. This produces our final image. Overall, we found ourselves satisfied with our results, especially compared to existing work, and would encourage other teams to try out non-photorealistic rendering techniques.